G'day team, welcome back to another video. So today we're going to be looking at solving trigonometric equations using algebra and our unit circle. So given that, if you do have a unit circle handy, please grab it out because you will be using it. So often our calculator might not do this for us exactly in terms of pi. Most modern day calculators will do this for us, but it is also really good to know how to do it by hand. So a couple of example questions that we're going to look at. Solving for x on the domain from x is from 0 to 2 pi. So the first question we're going to look at is 4 cosine squared x take away 3 equals 0, and we want to solve for x. Now, basically we treat this just as a regular linear equation solving for the unknown, whereas in this case we're solving for cosine x to start with. So with that, we're going to add 3 to both sides. All right, so now we've got 4 times cosine squared x equals 3. Now we want cosine squared x by itself for now, so we're going to divide both sides by 4. Now, cosine squared x, remember, is just cosine x all squared. The way we deal with a square is to take the square root. Now remember, we need both the positive and the negative version. So we've got plus or minus square root of 3 on the square root of 4, which is in fact 2. Now, once we have it at this point, so we're trying to get to that point of sine x equals cos x equals tan x equals. So we've got it in cos x equals. What we want to do now, we want to work out what angles give me a cosine value of positive or negative root 3 on 2. Now, this is where I want you to have a look at your unit circle. You should have coordinates on the edge of your circle and look for the x coordinate of plus or minus root 3 on 2. So you should hopefully find the angles. Pi on 6 has an x value of positive root 3 on 2. 5 pi on 6 is negative root 3 on 2. 7 pi on 6 is also negative root 3 on 2. And 11 pi on 6 is positive root 3 on 2. So these are all of the values for x that make our original equation true. All right, so that's example 1. Now example 2, we've got tan x negative root 3 equals 0. So again, we're trying to get tan x by itself. To do that, all we need to do is add root 3 to both sides. Now we're looking for an x value or an angle that gives me a tan of positive root 3. Now, if you're looking at your unit circle, hopefully yours has tan on it for you. If not, what you need to do is the sine value divided by the cosine value. And hopefully you find that x is equal to pi on 3 and 4 pi on 3. So there are 2 values for x that make this true. Awesome. So the other thing that they might throw at you, okay, so we're going to look at solving for x on the domain x is between 0 and 2 pi. So we've got 2 examples here. Now, the one thing I want you to be careful of is the argument or the angle has changed. So we're not just looking at x. So what we actually need to do, we need to change our domain so it matches our argument. This will make our life a whole lot easier. So if we're looking at sine of 2x equals root 3 on 2, we need our domain to have 2x in the middle, not x. So we've got our original domain, and to get from x to 2x, we multiply each by 2. So our new domain is 0, which is less than or equal to 2x, which is less than or equal to 4 pi. So you should have the 2 angles matching up just like that. Now, this is where it gets a little bit trickier. So we've now got sine x equals positive root 3 on 2, sine of 2x, sorry. What we need to find what angles give a sine value of root 3 on 2 for the domain from 0 to 4 pi. So 2x is equal to pi on 3, 2 pi on 3, and that is from 0 to 2 pi. Now we're looking at one more rotation, so we add 2 pi to each of those values. So now 2x equals pi on 3, 2 pi on 3, 7 pi on 3, and 8 pi on 3. Now to solve for x, we just have to divide by 2, which is just like multiplying the denominator by 2. All right, and we've simplified where we can. All right. So the key step is getting the domain sorted at the start and adding angles accordingly. So another example, cosine of x divided by 2 equals a half. Now we're looking at our x divided by 2, so that's not x, so we need to change that. So from our original domain, we need x to be a half of x, so we divide each by 2, and we're left with 0 is less than or equal to x on 2, which is less than or equal to pi. So the only angle that gives cosine of x divided by 2 equaling a half is pi on 3. So x on 2 equals pi on 3, times both sides by 2 to get pi by itself, and we're left with x equals 2 pi on 3 for our domain 0 less than or equal to x on 2 less than or equal to pi. So there are a few strategies that you can use to help you attack these questions. Thanks for listening, and we'll see you guys next time.